This video introduces a TRINITY module connecting virtual model with the physical model with the integrator version of showcase how robot and other machines can be connected. In this video, I will first explain the system requirement and the structure, and then start the OPCW server in the server PC, and also start the OPCW client with other programs for each robot. And finally, I will change the values in the server and to move our physical robot. The system can connect with multiple robots. Here I take two robots as the example in this picture. One robot is a standard 6-axis Nachi robot, and another one is a 4-axis Scala robot. But in the following videos, I will mainly show you the Nachi robot. Some newer industrial robots have open API for low-level control and the inverse kinematics, but these two robots have no such functions, so we added a middleware PC for each of the robots. The middleware PC is an Intel i5 Nuke PC, which is running Ubuntu 18 system. The middleware PCs are responsible for the inverse kinematics, robot joint PID control, and the OPCW client. In our system, the inverse kinematics, PID control, and the OPCW client are all Python programs. They can communicate with each other. The PID control and the inverse kinematics are dependent on robot systems. For some newer version of robots, they don't even need to develop these two functions. They have already embedded. So in this demonstration, we will not show you how to develop the inverse kinematics and the PID control. For our server PC, which is running the Windows 10 system, the main OPCW server, which is also a Python program, will running in the server PC. The client PC can start UA Expert to access the OPCW server to view or change the server variables. Now I will show you to start our OPCW server in our server PC. It is a simple process. Just run PyCharm in your PC and run the code for the main server. Then I can show you to start the OPCW client and the inverse kinematics in our robot. I'm remote login to our middleware PC, the Nuke PC, through the team viewer, and we just run the inverse kinematics and the PID control with the OPCW client with simple code. Then we can go to our Windows PC to start the UA Expert and connect UA Expert with our main server. Then we can see the TCP values is unreachable, so the inverse kinematics is fail. Then we change the TCP value to some reachable value. Then the inverse kinematics will calculate the correct joint value and feed to the server. Now I can show you to change the values in server that move our physical robot. In this video, I changed our server value for several times through the UA Expert, and you can see our robot is moving according to our changed position. Due to the safety concern, we have limited the robot speed to a very low speed, so the robot cannot move very fast. If you are interested in more tutorials on this module or other use cases, please follow the links in description. Thank you for watching this TRINITY video.